In this video, I'm going to show you how to add, subtract, and multiply imaginary numbers. The definition of an imaginary number is the square root of -1. Another way to kind of think about this in terms of squaring, since square root is the inverse of taking to the second power, or squaring, is what number, when multiplied by itself, that result is -1. So that number does not exist. This is where that imaginary number comes from. A little bit history on that, right? Imaginary numbers were once thought to be impossible. That is the reason why they are called imaginary. It was actually to make fun of them. People started getting into researching these imaginary numbers and found out that it was actually useful and important, because actually it gapped or it bridged a lot of gaps in imaginary, but the actual terminology imaginary just stuck with it, because imaginary just got stuck with that terminology, right? That's one of the reasons why real numbers came about, because now we have imaginary and real numbers. All right, let's move on to a property of imaginary numbers that's going to be used when we simplify, after we multiply these imaginary numbers. All right, so I for the imaginary number is equal to the square root of -1. If we multiply I with itself to get I squared, this is pretty much the square root of -1 squared, which result is -1. I to the third is the same thing as I squared times I, which is -1 times the square root of -1, which is the negative square root of -1. No, this negative cannot go inside to distribute in here. It stays like this. And then I to the fourth power becomes I squared times I squared, which is -1 times -1, which is +1. If I do I to the fifth power, that becomes I to the fourth times I, which is +1 times the square root of -1, which becomes the square root of -1. So you see, it kind of came back to repeat itself. One thing that I forgot to mention, right? The square root of -1, right, becomes -I. Here's the I, and then that's the negative. Once we know this, right, after knowing that it comes back here, it's going to end up repeating. If I have I to go this way, I multiply with the second I, the result is going to be -1, which is I squared. If I multiply again with an I, that result is going to be -I. If I multiply it again with with just I, this result is +1. And if I multiply this +1 times I get back to I. So this pattern is going to repeat itself over and over and over again. So to add, subtract imaginary numbers, we're going to treat them just like terms. Real numbers combining with real numbers, and imaginary with imaginary. And then we are going to simplify. So this first example, I have 8 minus 7i plus -6 plus 5i. So I can rewrite this as 8 minus 7i. Since I am adding this binomial, I'm just going to stack like terms to this, and now I'm just going to simplify. 8 plus 5 is 13. 7, -7, and -6, that is also -13. These imaginary components do not combine to make something else, because again, they are treated like terms. So this here is the final answer to this here. Example 2. I'm going to simplify 8i minus the binomial of -5 minus 5i. Since I have a negative here, I'm going to distribute into this binomial. So I have 8i plus 5, negative times negative positive. Negative times negative I said was positive, 5i. Out of these, 8i and 5i are like terms, so 13i, and then I have plus 5. There is nothing wrong with having this as the final answer, but this is called a complex number. Complex because it's made up of real and imaginary. Usually it is in the form of this here, which means A is the real part, and B, in this case, it is the imaginary. Like I said, there's nothing wrong with showing this as the final answer, but you're going to see a lot of books, a lot of final answers to be this as the final answer. Multiplying imaginary numbers, we're going to multiply them just like polynomials. Instead of x being our variable, we're going to think of I being our variable. We're going to simplify, and we're also going to use the imaginary number property that we saw earlier in the video. In example 3, we are asked to multiply 6 minus 7i times itself because of the square. In order to do that, right, it's easier to see if we have 6 minus 7i times 6 minus 7i. I like telling my students to use the Punnett square for multiplying polynomials. This is 2 and 2 terms as well. So 2 terms, 6 minus 7i. Here's one polynomial, and here is the other polynomial. 6 times 6 is 36. 6 times negative 7i is negative 42i. Negative 42i. Negative 7 times negative 7 is positive 49i to the second power. As you can see, these two are like terms. So I have 36 minus 84i plus 49i squared. Now to use the imaginary property. Now we use the imaginary number property. Earlier we saw that we had I, -1, -i, and +1. Going this way, when we multiply by I, this is I squared is -1. So we're going to substitute -1 in here. 36 minus 84i plus 49 times -1. This is -49 and 36. So 49 minus 36, that's 13. Negative is bigger, so -13 minus 84i. And this here is how we simplify this example. Next example, we're asked to multiply 2 with -7i times -5 minus I. We're going to multiply this to 2 and -7, that's -14i. That is being multiplied with -5 minus I. This is just distribution. negative 14 times negative 5, that is positive 70i plus 14i squared. Again, I squared is negative 1, so positive 70i plus 14 times negative 1. So all this becomes negative 14 plus 70i. And that is our result.